The standard engineering approach was to force all of this into a single, massive codebase. But as these digital environments continue to rapidly grow, those giant unified structures begin to buckle under their own weight. When hundreds of developers have to work inside one monolithic front-end, every minor update risks breaking the entire system. Deployments slow to a crawl, testing takes days, and feature velocity simply stops. The solution to this bottleneck is an architecture known as the Micro-Frontend. Instead of building one giant website, you are breaking apart the front end into smaller, independent applications. By doing this, a company can assign total ownership of a specific feature to a dedicated group. One team controls the shopping cart, another manages the user profile, and a third runs the product recommendations. These individual teams don't even have to use the same tools. The checkout team could build their section with React, while the legacy profile page continues running smoothly on Angular. Even though the code is developed and maintained in complete isolation, those distinct pieces are stitched back together in the browser, so the user only ever sees one seamless web page. This setup solves the human problem of managing large engineering teams. But by deliberately fracturing the codebase, developers accidentally created a massive new technical hurdle. If every micro app is completely walled off from the rest, sharing basic necessities becomes a logistical headache. A simple login component used across 5 different pages suddenly has nowhere central to live. To compensate, each independent section might bundle its own copy of a utility library. The result is a bloated website that forces your users to download the exact same code multiple times, destroying page load speeds. The friction worsens when 2 parts of the page try to load different framework versions simultaneously. The scripts crash and components reject each other. Traditional compiling bundles code at build time, meaning it cannot resolve these dynamic clashes on the fly. To make this architecture viable, developers needed a completely new mechanism, one that would allow isolated sections of a web page to negotiate and share their resources live in the browser. That mechanism is Module Federation. Introduced initially as a feature for Webpack, it shifts the heavy lifting of dependency sharing away from the initial build process, moving it directly to runtime. One application acts as the host, the central traffic controller. Other micro-applications are remotes. When the host needs UI, it requests it from a remote, which delivers the functional component. It intelligently checks dependencies, skipping redundant downloads if the host already has it. All of this complex negotiation and code sharing happens completely in the background in a fraction of a second, while the user is actively navigating the site. By managing dependencies on the fly, Module Federation strips away the risk of duplicate downloads and version crashes, finally making the micro-front-end approach practical to use. With the technical barriers cleared, engineering teams can fully realize the primary advantage of this system: sheer deployment velocity. Because the codebase is successfully decoupled, a single team can iterate, test, and ship updates to their specific feature 5 times a day without ever touching or endangering the rest of the application. And if a user is actively on the site when that update hits, their browser doesn't need to refresh the whole page. It simply live streams the changes to that one isolated component. This combination of decentralized teams and dynamic code sharing has become the standard mechanism for major tech enterprises to coordinate hundreds of developers simultaneously. A micro-frontend is the architectural strategy to break things apart. Module Federation is the technical execution that lets them work together. Together, they dismantle the monolithic front-end problem.